Okay, so first question says find f of 14. So since they've given us a function f here, all you're doing is substitute 14. So a f of 14 would be 14 plus 2, which is the square root of 16, which is 4. Right, find g of f 14. So here we need to find f of 14. Lo and behold, we just did that. And then we have to substitute that value into g. So we're now finding g of 4. So it's 3 lots of 4 take away 7. Oops. Okay. G minus 1. So the minus 1 indicates its inverse function. So we start off by saying y equals, switch for x and y, rearrange, and oops, y. And so g minus 1x is x plus 7 over 3. Right, we know the derivative is this. We're asked to find fx. So if we're given the derivative and asked to find fx, it means we're going to be integrating. So the integral of 6x squared minus 5 would be 6x cubed over 3 minus 5x plus c. Okay, we mustn't forget the plus c. This simplifies to be 2 over 1, so that's 2x cubed minus 5x plus c. They gave us some additional information to now enable us to find c. So we know that negative 3 is equal to 2 lots of 2 cubed minus 5 lots of 2 plus c. So negative 3, 16 take away 10 is 6. So c is negative 9. So that makes our function 2x cubed minus 5x minus 9. Okay, so number 3. So we've got fx is 3 sine pi x. Write down the amplitude. Okay, so the amplitude is given by the value in front of the function. So that would be 3. The period. So the period is determined by the value in front of the x. So normally the period would be 2 pi over that value. Let's say b, period. So the period is 2 pi over pi. Pi's cancel, which means the period is 2. If we're going to sketch this graph, we know it's a sine, so it starts at 0, 0. We know it goes up to 3 and down to minus 3, and takes 2 units to do a full cycle. So I'm going to take my 2 units as a full cycle and cut that into 4 pieces, which is what we're used to doing. I know I start at 0, 0. I know I go up to 3, down to minus 3, up to 2. And I'm going to continue it because they want it to go on to at least 3, which means I'm going to go up, down, down, up. Okay. Box and whisker plot. So write down the median score. Median score is shown by this value here, so that would be 60. The range of scores is 47. So the range means it's this value subtract this value. So that C subtract 40, I know is 47. And so C must be 87. interquartile range is given by this value, subtract this value. So 74 subtract D is 22, which means 74 subtract 22 is D. D is 52. An arithmetic sequence, first term is 8, second term is 5. Find the common difference. Well, if I know a sequence is saying 8 and then 5, for a start I know it's going down, so that would be -3. Find the 10th term. So here it may help to look at the formula booklet. It's an arithmetic sequence, so let's just get this stuff here for now because we might need the other bit in the next bit. So that's from our formula book. We know that this is the one that talks about term numbers, so B would be U10, would be U1, which they told us was 8, plus 10 minus 1 lots of -3, excuse me, equals 8 plus 9 lots of -3, 8 take away 27, which is -19. Right, okay, find the sum of the first 10 terms. So this time we're using the sum formula, so we've got two different versions of that, and you could actually use either in this case because we know the 10th term, but this is probably the more common form we would look at. So CS10 would be 10 over 2, 2 lots of 8 plus 10 take away 1 lot of -3. So that's 5, 16, so 9 lots of -3 is -27. Oops. 16 take away 27 is -11. So that's -55 is our sum. Right, so x is ln3 and y is ln5. Write the following expressions in terms of x and y. So ln5 over 3. So let's go back to our log. Okay, so this is from the formula booklet. Remember the base doesn't really matter. When it's ln, it's base e. Ours looks a bit like this, which means that we need to separate it somehow to look like this. So if we've got ln of 5 over 3, comparing it to this one here, it means it would be ln 5 take away ln 3. Comparing that to up here, that means that that's, oops, it's not x take away y at all. That means it is y take away x. So B. Now, ln45 doesn't look like anything we've got here. However, we've got a 3 and a 5. And we're looking at 45. It's just one of those things I think you just need to practice and recognize that 45 can actually be written as ln 9 multiplied by 5. That in turn can be written as 3 squared multiplied by 5. And so this here now looks similar to this, where you've got two things multiplying together, which means that we can separate them by adding. So that means that this is going to be ln 3 squared plus ln 5. Now the squared is causing us a bit of an issue, but handily this here, if we've got log of something with a power, then our power can just come in front. So the information is all in the formula book, but you just need to know where to look for it. and what to do with it. So the power can come in front. So we've got 2 ln 3 plus ln 5. And similarly, ln 3 is x, and ln 5 is y. So we've got 2x plus y. Okay, next. Okay, right, so we've got fx and we've got gx and we're finding fog. Right, so g is going into f. So replacing any of the x's in this function here. So any of the x's is now going to be written as cos x. So we've got 6 cos x, 1 minus cos x squared. I've written it in that on purpose because just to recognise what's going on. Now, here we need to know that the cos x all squared is normally written as cos squared x. Now, at this point, we need to start thinking, right, well, they've now changed what we've got here to a sine. So we're probably going to be using our formula booklet. So we find our formula booklet and let's snip all of these to see which ones are going to be useful. Okay, so 1 minus cos squared. So we're looking at these things here, seeing which one might be useful. Well, this has got 2 cos squared and a 1. This is the one we're interested in here. So this one here can actually be rewritten as 1 minus cos squared would be equal to sine squared. So that means I can change this to be 6 cos root sine squared. Well, hopefully you're appreciating that when you square root a sine squared, you're just going to have sine. Oops. Shall I actually write the x's rather than just writing cos? And they should all have an x. Sine x. Alright, so now we've got 6 cos x sine x, but they just want it in terms of sine something x. So we again need to look at our thing. So if we're saying change it to a sine something x, that looks like this one here. So we need to have a look. Can we change it to look more like this? Well, you can say that it's 3 lots of 2 cos x sine x. Now I'm assuming you're all appreciating that cos x sine x is the same as sine x cos x because they're multiplying, so the order doesn't matter. So we can now, instead of writing 3 2 cos x sine x, we can write 3 sine 2x. And there we go. We've written it in the format that they wanted. Oh, there's a B. Hence, find the range of h. Okay. Oh my goodness. The range is the y values. Okay. We need to know our knowledge of sine graphs. That this value here is going to change the amplitude, which affects the range. This number here affects the period, which affects the x values, or where the x values are situated, or how long it takes to do a cycle. But that's not important for this particular question. So it's this we're interested in. So that means that we know that this particular graph would be going up to 3 and down to -3. So however you write that, it's your call. But there we go, that's our range. Okay, there's our function. Show that f-1 is 1. So f-1. So this is where we pick section B. So we have to start each new question on a new piece of paper. Obviously I'm not going to because it's a smart document. but please make sure you do follow those instructions when it comes to the exam. Right, so f dash x would be 2x, take away 1. So power comes in front, take 1 off the power, and then there's a secret 1 in front of there, which gives us our 1 here. They want to know f dash 1, so it means substituting 1 into here. 2 of 1, take away 1. And there we go, we've shown that. And the line L is normal, is the normal to the graph of f at p. Find the equation of the line L in this format. Well, this here tells us about the gradient of the tangent. Okay, remember that's always been what the derivative tells us. If they want to know the gradient of or the equation of the normal, then we need to know, or we need to identify the gradient of that normal. We know that tangents and normals are perpendicular to each other, which means that our gradients would multiply to give -1, which means that they are negative reciprocals of them, which means that this value a for our question has to be -1, because that's the negative reciprocal of 1. So our equation is going to start off with y equals -x plus b. I'm using the same letters as they've got here. Now, the normal is going to go through the same coordinate, okay, because they're talking about the normal at p. So we're using this coordinate. So that means that we're going to say that 0 equals -1 plus b, which means that b is 1, which means that our equation of our normal is y equals -x plus 1. Okay. Right, the line L intersects the graph at another point. Okay, find the coordinate of Q. So we know that our equation, our line L, meets our original at another place. When we're finding points of intersection, we're solving simultaneous equations. So I'm going to sneak it in this little section here. So we know that x squared take away x will equal our equation. So ours was -x plus 1. That's what we're solving now. And we've got -x on both sides, so they cancel each other out. So we've got that x squared is equal to 1, which means that x is the square root of 1, which means it's plus or minus 1. Remember, when we square root at this level, we've got to remember both options. Now, we've already been investigating this situation here, where it's +1. So now we're going to be looking at it when it's -1. So they want to know the x coordinate of Q, so that's -1. Find the area of region enclosed by the graph of f and the line L. Well, we know that areas between graphs are given by the integral, and our 2 points, our 2 limits, are +1 and -1. No, I don't think it is in here, is it? Just trying to remember. No. No. So it doesn't. You do need to remember which way around it goes. Now, the fact that this line is on top means that that's the one we're going to start off with. So it's going to be the integral of, what's the equation of that? -x plus 1. Is that what it is? Yeah. Take away, what's the function? X squared minus x. And that's between 1 and -1. 1 and -1. They're both dx. That's really badly written. Remember, you can join these together first. So you can say it's -x plus 1. Subtract x squared minus 1. So that's negative x plus 1 minus x squared plus 1. So that is okay. I've done something wrong there. Let's oh, it's minus x. X squared minus 1. Oh, x squared minus x. So that's plus x. So these cancel each other out, not the ones. Oh, that's a big mess up. So we're trying to find the integral of 1 minus x squared dx between 1 and negative 1. But rather than make a big mess of it like I did, mind you, I had the wrong thing up here as well. So anyway, we're finding the integral between these two. So we're going to integrate 1 minus x squared. So the integral of 1 becomes x, and x squared is x cubed over 3 between 1 and minus 1. So it's 1 minus 1 cubed over 3. Subtract negative 1 minus negative 1 cubed over 3. So it's 1 minus 1/3. Subtract negative 1. And then we've got negative 1 cubed is negative 1 over 3. We're taking that away, so that becomes plus 1/3. So we've got 1 minus 1/3. Then we're taking away both of these two things, so that becomes plus 1 and minus 1/3. So we've got 2 whole ones minus 2/3, which gives us 1 and 1/3. Okay, or you could have written 4 over 3. This could happen, so you need to be able to deal with fractions when it comes to the non-calc paper. So if you're looking at this thinking you're not sure what's going on, then we need to work on that. If you had wanted to change all of these things to thirds, this would have been 3/3. Take away 1/3. Take away negative 3/3 plus 1/3. So you could have worked out, I guess, these two bits separately. So 3/3 take away 1/3 is 2/3. And then negative 3/3 plus 1/3 is negative 2/3. And then this becomes plus, which gives you 4/3. So there's lots of different ways of working these out. However you do it is your call.